Today, we will solve the problem 8.1 of Griffith third edition Introduction to Quantum Mechanics. The problem 8.1 is use a Gaussian trial wave function equation 8.2 to obtain the lowest upper bound you can on the ground state of uh, there are two sections. One, the linear potential V of x is equal to alpha modulus x, and the quadratic potential V of x is equal to alpha x power 4. Now we will solve the part A. The part A is uh, that is a trial wave function given in equation 8.2. This is equation 8.2. That is, it is in the Gaussian nature. Psi of x is equal to a e power minus p x square. Uh, we know first we have to find the normalization constant a here. So for that you have to integrate between minus infinite to plus infinite, uh, plus infinite. Psi star psi tx is equal to 1. Here psi is a e power minus px square. So psi star psi is equal to modulus a square integrated between minus infinite to plus infinite, e power minus, if you multiply this twice, take the square, e power minus 2p x squared tx, which is which must be equal to 1. Here we know from the Gaussian integral, the value of this integral is uh, pi by 2p. That is e power minus alpha x squared. If you integrate between minus infinite to plus infinite, you will get the value of square root of pi by alpha. Here alpha is 2p. So which is equal to 1. If you bring square root of pi 2p to the right hand side, you will get modulus a squared is equal to square root of 2p over pi. So now we have to find the expectation value of kinetic energy. The expectation value of kinetic energy is equal to uh, psi a p psi you will get. So this p you are replacing by its operator, which is equal to minus h cross square over 2m t2 over tx2. So now you differentiate this expression once. This is a second order differential equation. You differentiate once, then you will get um, uh, 2p minus 2px minus 2px. So this minus of minus will become plus, and 2 will cancel with this 2. So I have replaced the h cross squared by 2m as h cross squared over m, and I have taken p also outside. Minus 2p I have taken outside, and 2 minus cancelled with this. Then I will get um, integral between minus infinite to plus infinite e power minus px squared. Then we have to differentiate this again with respect to x. Now we got this integration. Uh, Now again you differentiate this exponential x in the exponential term once. Then first you differentiate with respect to x. This x tx will become 1, so you will get only the exponential term. Then you differentiate the exponential term, leaving x as it is. If you differentiate this exponential term, you will get minus 2px. Already there is one x. This will become 2px squared, then that exponential term. Now you take this exponential term outside. This exponential term outside. Sorry, not this. This exponential term outside. then this will become e power minus 2px squared, and here you have 1 minus 2px squared. So now you can separate this into two integral. One is you multiply this by 1, then you will get e power minus 2px squared. Then you have minus 2px squared. You take minus 2p outside because it's a constant. Then you will get x squared e power minus 2px squared dx. So we have to integrate these two. Now, just now in the case of normalization constant, we find the value of this integral, which is equal to square root of pi divided by 2p. And now we have to find this integral value. Here, from Gaussian integral, integral between minus infinite to plus infinite, x squared e power minus beta x squared dx is equal to 1 over 2 square root of pi beta power minus 3 by 2. So this you can take it. So if you take this, now I am replacing my 2p as beta, this 2p as beta. So here instead of beta, I am replacing 2p. Other thing I am taking out, that is uh, of square root of pi into 2p power minus 3 by 2. Now you can cancel this 2 and 2. Here you can cancel this 2 and 2. So now we will solve this problem. Now we got this expression. You can further simplify this. Minus p square root of 2 into 2p power minus 3 by 2. This minus 3 by 2 we can bring to the denominator. It will become plus. So 1 over 2p power 3 by 2 can be written as 2p into square root of 2p. So here this p will get cancelled with this p. So now you multiply this by you bring this term inside. That is square root of 2p over pi. So this will this and this will get cancelled. It will become 1 minus, and the second term square root of pi divided by 2p will get cancelled with this if you bring this into inside the bracket. So this will be already p got cancelled. This is minus 1 over 2, minus 1 over 2. So here you have outside the bracket you have h cross squared over m p, p in the numerator. So h cross squared uh, over mp. Here first term will become 1, second term minus half. So 1 minus half is plus half. So this will become h cross squared p over 2m. This is the expectation value of the kinetic energy. Similarly, you can find the expectation value of the potential energy. So potential energy, it is given in the problem, it is linear alpha x. So I have taken alpha x e power minus 2p x squared. This modulus a squared is, we know, square root of 2p over pi. So now now you can change the variable. Let us take y is equal to 2p x squared. Then if you differentiate with respect to y, that is dy will become this 2x. This will become 2x. Already there is 2. So this will become 4px dx. So naturally, if you bring this 4p, it will become dy by 4p, which is equal to x dx. So you can replace x is here and dx. I'm replacing x dx by dy, and minus here I am replacing 2px squared as y. So I am changing this integral from minus infinite to 0. So I have to multiply this by 2. So that is the reason why here I got 2. So this value of this integral is well-known integral between 0 to infinite. Its value is 1 plus 1. So naturally you will get this square root of 2 p over pi alpha uh, 1 over 4p into 2. Now this 2 and 2 will get cancelled. 4 will get cancelled. This will become 2. So this is 2p. So this can be written as uh, 2p can be written as a square root of 2p into square root of 2p. So 1 over 2p can be written as square root of 2p into square root of 2p. So 1 square root of 2p will get cancelled with this square root of 2p into denominator. So that will get cancelled. Then you will get in the denominator only square root of 2p. So naturally, in the denominator already there is a square root of pi, and it is a square root of 2 pi p in the denominator, and alpha you have in the numerator. That is, this 2p, square root of 2p will get cancelled with 2p, and it will become square root of 2p. So now we got the potential energy. Potential energy, expectation value of the potential energy is alpha divided by the square root of 2 pi p. Now we will see the minimum energy. Now we have to find the expectation value of Hamiltonian, which is nothing but the sum of the expectation value of the kinetic energy and potential energy. The expectation value of the kinetic energy is h cross squared p over 2m. For potential energy, it is alpha divided by square root of 2 pi beta. Now, in order to find the minimum value of the Hamiltonian, you differentiate this with respect to p, because p is the adjustable parameter, it will become naturally 0. If you differentiate the first term with respect to p, then it will be h cross squared over 2m. Then what about the second term? Second term, p square root of p can be written as p minus power minus half. It will become in, it will come into numerator. So if you differentiate this, what you will get? If you differentiate, you will get minus of p minus of minus 1, which is equal to minus 3 by 2. So we got this minus alpha divided by 2. This 2 comes here. Uh, p power minus 3 by 2 divided by square root of 2 pi, which is equal to 0. So only here you have parameter p, and if you bring this to the other side, you will get h cross squared 2m. This thing will become h cross squared to 2m, and this is simply mathematical things. So from this you can find p, which is equal to m alpha divided by square root of 2 pi h cross squared power 3 by 2. Uh, then you substitute this here in this expression. You replace p by this term and square root of p by this term. Then finally, after simplification, you will get 3 by 2 into alpha squared h cross squared divided by 2 pi m whole power 3 by 2. This is the minimum value when the potential energy is linear. That is, potential is uh, potential is alpha modulus x. So now we will move on to the next part. We will see what will happen if potential is quadratic one. Uh, Now Part P is potential energy is alpha x power 4 is a quadratic. Then we have to find the expectation value of V, that is modulus A squared, which is equal to square root of 2p over pi, we know. Then we have to find the expectation value for alpha x power 4. Alpha I am taking out as it is a constant, and x power 4 inside this integral. So from Gaussian integral, value of this integral is 3 pi 4 square root of pi beta minus pi by 3. Here beta is 2p. 2p is beta. So for this integral, I am replacing 3 by 4 square root of pi 2p minus pi by 2. Now, what I am going to do is this 2p minus pi by 2, I can write 1 over pi by 1 over p power pi by 2, which can be written as square root of 2p into 2p whole square. Now, we can cancel some of the parameter. This 2p square root of 2p over pi. So this pi cancels. This square root of 2p will cancel. So we will get alpha in the numerator. We will get 3 alpha 3. In the denominator 4 into 2p squared, 2p whole squared. So 2p whole squared is 2 squared is 4 and p squared, 4p squared. So this will become 3 alpha divided by 6p squared. This is the expectation value of the potential energy. There is no change in the kinetic energy. Kinetic energy we will take the result of part A. Now, the expectation value of the Hamiltonian is the sum of expectation value of kinetic energy plus potential energy. Kinetic energy we have seen h cross squared over h cross squared p over 2m. We have seen it in part A. Then plus now we have seen the expectation value of potential energy 3 alpha divided by 16p squared. Now, if you differentiate this in order to get the minimum value, it must be equal to 0. So, the first term will become h cross squared over 2m. The next term, the 1 over p squared can be taken as p minus 2. If you differentiate this, you will get uh, minus 2 p power minus 3, which can be written as pq minus 2 divided by PQ. So this 2 will cancel with this 16, which will become 8, and this P squared will become PQ. So this second term is minus 3 alpha over 8 PQ, which is equal to 0. So you have P in the second term only. If you equate both, you will get P is equal to 3m alpha divided by 4 h cross squared power 1 over 3. So if you substitute this here, p and p squared, you will get minimum energy is 3 by 4 multiplied by 3 alpha h cross power 4 divided by 4m square whole power 3 by 2. This is the uh, minimum energy. So thank you very much for watching my video and supporting me continuously. Thank you very much.